jump right into class here. So let me pull up our screen. Well, let me get it. Let me get the screen up here. And let's put our programming up on the screen, see what we're tackling this week. We don't have much time left. We got 2 weeks of class and then a semester final. So that's not much time. So if you're behind on programs, this is an A-day Friday. So you've got Wednesday and Friday this week. Okay, programming. Let's go to our grade screen. We scroll all the way down. This week we have while loops. Last time we had for loops. This week we have while loops and then creating functions and then our exam. So we have two assignments left and our final exam, which will be an exam. It's not a program. It's actually questions and all that good stuff. You may write some code in the exam, but that's what we have. So let's go to 3.03 and see what it looks like this week. While we looked at for loops. While loops are similar, but they work a little bit differently. Remember, for loops counted, you'd like start at 0 and go to 10 or something. So it'll count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then would stop when it gets to 10. So while loops will be similar. So boundaries are a good thing. When you're full, you stop eating, hopefully, or you get really huge. When you're tired, you start sleeping. When your phone dies, you plug it in. Well, you try to follow these boundaries anyway. Whether it's your stomach, your energy level, your battery life, each has a boundary that indicates that something needs to start happening or something needs to stop happening. And in programming, boundaries work the same way. So we're going to learn how to compare for and while loops and how they're used, explain how while loops, the structure of those, identify the boundary conditions needed for while loops, and use a while loop to perform repetitive tasks. So let's get into the while loops here. So loop types. When you want Python to repeat some action, you use a loop, which we learned last time. There's two kinds of loops, for loops and while loops. So we're familiar with the for loop. The structure is commonly used to count through some range. We know how many times we want to repeat it exactly. So we said for x in range, start counting at 0, 1, and 10. Count by ones, go to 10. Now, a while loops, we really don't always know exactly how many times, but a lot of times we can. But we're checking for something to happen. So it tells Python to repeat the action while something is true. So if you don't know exactly how many times, you might use a while loop. But here's a simple example. This one we know how many times it runs. So we said we're going to set x equals to 0. And then while x is less than 10, keep doing this loop. Just keep doing this all while x is less than 10. And at some point, x will be equal to 10 and it will stop. So all that's happening inside this loop is we're just taking x and we're adding 1 to it every time it goes through the loop. So this one we know will just run 10 times because it's adding 1 to it every time. And so when it gets to 10, it'll stop. So here's a comparison, a nice Venn diagram. So for loops, exclusively to for loops, repeat for a set range of values. The loop variable is given a start value, and this is best used when you know the exact number of repetitions needed. Now, the while loop, let's go over here to the exclusive to the while loop, while loops only. They repeat while a Boolean condition is true. Boolean means you're comparing it like less than or equal to, greater than, that's Boolean conditions. So while that condition is true, it's going to keep repeating the loop. The loop variable is assigned a value before the loop. So before the loop, we say, here's whatever value, x equals this or whatever. This is best used when you do not know exactly how many repetitions you're going to need. Now, here's what's true of both loops. Both of them repeat the block of code that's in the loop, and both of them will stop once the condition is false. Page 3. Worth your while loops. They got a little clever with the phrasing there. Worth your while. Like here's a loop you see on Netflix. Are you still watching? It's been 16 hours. You're covered in chips. Really, think about it. Continue watching. Imagine you and your friends are binge watching your favorite new show. Binge watching that. probably like Third Rock from the Sun or something. There are 7 seasons, and you're going to watch it until you see the series finale. I mean, it's going to be a long but epic weekend, right? 7 seasons. Something keeps happening. Every time an episode ends, this pop-up screen. Are you still watching? Can I stay awake for another one? Right? That's what you're thinking. Yes, I'm still watching because I can stay awake for another episode. This is when a while loop would be useful. You have to ask yourself, while I can stay awake, keep playing the show. You could say, while there's still episodes left, keep playing the show, right? We use while loops to repeat actions when we can't find the number of necessary iterations easily. Well, there's no way of knowing the specific number. Like, I don't know what point this weekend I'm going to have to sleep. So just while I'm still awake, let's keep repeating. I can't say run 8 episodes because maybe I fall asleep in 6 episodes. Or maybe I want to watch 10 or 11 episodes because I'm still wide awake after the 8th. So that's where a while loop is better than a for loop. So there's some important syntax points to be aware of when you write that. So first of all, this statement begins with the keyword while, right? The other one starts with for, so this one starts with while. The test condition goes inside the parentheses. The statement ends with a colon, as a lot of our statements do in Python. And the code in the body of the loop gets indented. So here's an example. Answer equals yes, or y. Answer equals y. We have this variable we created called answer, and we're going to give it a value of y. And while, here's our loop, while the answer is equal to y, remember you have to put 2 equals to test something. Remember, Boolean, we have to put 2 equals for testing. If we just put 1, that's like the first statement. We're setting it equal to that. So this is checking while answer is equal to y. Keep doing this loop. So it says Trixie circle 25, Trixie left 25 pixels. So it draws a circle. This is obviously a turtle thing, right? We've created a turtle. We named it Trixie. We told Trixie to draw a circle of radius 25 and then move left 25 pixels. Then it says, would you like to draw another? And so you either hit Y or N. If it hits Y, it's going to loop through there again. It's going to draw another circle. It's going to move the turtle left 25 pixels. If you hit Y, it'll draw another circle. Move the turtle left 25 pixels. When you hit N, now it'll end. Now see, but we didn't do a for loop because we don't know exactly how many circles we want to keep drawing. Until somebody hits N, it's going to keep drawing. So the while loop needs to know 2 things. What action am I doing? What's part of the loop? And what's the conditions? Like for this one, the condition was as long as the answer is still equal yes, keep doing the loop. So these are a few instances that work like while loops. While it's raining outside, use an umbrella. On the condition that it's raining, you're going to use an umbrella. Once it stops raining, you won't use the umbrella anymore because that's kind of silly. Right? Walking around after it's rained with the umbrella stuff. While there's still ripe fruit on the tree, pick it. Right? If there's not, don't pick it yet. You don't. This logic works both ways, right? So while the ride is in progress, keep your hands, arms, feet, and legs inside, right? Because you don't want to lose any of those pieces of your body. And that's always true while the ride's in progress. Once the ride's over, then you're good. While I'm following you on Instagram, I can see your photos, right? And that loop will be true as long as I continue to follow. But when I unfollow, now I can't see it anymore because the loop ended. That's how while loops work. Hashtag that's how while loops work. All right, page 4. Let's look at some actual while loops in action. So Python uses what's known as Boolean logic. That's a condition that evaluates whether something true or false to determine whether the condition is true or false. The loop will repeat the action as long as the condition provided is true. And as soon as that condition becomes false, the loop will end. So here's what we use in Python. Here's the algebra equivalent. So in algebra, when you see less than or equal to that looks like that, in programming, we have to do 2 things. We got to do less than and we got to do equal than. So that's the same thing that you see in algebra as this. Less than is exactly the same. Equal to, in algebra, we just use an equals. In programming, we have to do 2 equals side by side. We can do not equal to by putting exclamation point equals. When this is not equal to this, stop the loop. Greater than is exactly the same, and greater than or equal to. So here's a great place that you can refer to when you're writing your program next to figure out how to do the greater than, less than, equal to, all that good stuff. Look at page 4. So we're going to use one of these 6 relational operators. So they're pretty familiar from algebra, but sometimes the symbols are a little different. So let's take a look at our practice programs. And if you're not getting in here and play with these programs, then you're probably struggling to write your own program when you're assigned that, because you need to go in and practice with these and learn how these commands work. All right. Hashtag the while loop. There's our comments at the top of the page. Here's our defined main statement. That's part of every program we write, and the end of the main statement. So all of this is our main function. So at the beginning, we set x equal to 0. Okay, so that's the first thing we did. We said x will be equal to 0. And while x is less than 5, I want you to do the following loop. First, I want you to print what x equals. And then I want you to add 1 to x. And then it'll go back up and check this again and say, is x less than 5? It is. So I will print it and add 1 to it again. Is it less than 5? Yes. I'll print it and add 1 to it again. And it'll keep doing that until it equals 5 or is greater than 5. But as soon as x is not less than 5, it will stop. So let's run the program and look. We expect it to do what? It'll print 0 because that's what it's equal to the first time. Then it'll go through the loop again and it'll say, oh, yep, I need to print again. It'll print 1 and print 2. So let's look at it. There it is. It prints 0, 1, 2, 3, 4. Why did it not print 5? Because when x is equal to 5, this is no longer true. Because it says while x is less than 5. So when x equals 5, it'll jump out of the loop. It says, I'm done with the loop because this is no longer true. X is not less than 5. So when it got to 5, it quit. There was nothing else left in the program. So it ended the main function and it was finished. All right, let's look at the next slide. There's 7 of them down here. We're going to see a lot of examples. Read the code, try to predict the output. Okay, the code looks exactly the same. Nothing changed. While x is less than 5, print, run the program. It says modify the range of the while loop so the count is from 1 to 10. Okay, so from 1 to 10. So start with 1. And it wants us to count to 10. So we want to run the loop as long as x is less than 11. So the first time through, x is going to equal 1. So it should print 1 and should keep printing until it gets to 11. Then it'll stop. There it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, great job. By starting at 1 and doing while x is less than 11, we can print 1 to 10. So that's 10 loops repeating those 2 lines of code. All right, starting to make sense of this while loop, what it's doing here. And we can have it do other things inside the loop. I'm just showing you how the loop works. Let's look at the third slide. Oh, now we've got import turtle, so we're going to draw something. Here's our main function. We've got our turtle named Rosemary. Told her to move at speed 10, grab her purple pin, pick your pin up, and move over to position 050, and then put your pin down. All right, turtle, get your purple pin, move over there, put it down. And this, we've got this variable that we called num circles, and we're going to start it as 10. That's what num circles equals to. So we've got our x equals 0, and we said while x is less than num circles. So while x is, it's going to start out while 0 is less than 10, because x is 0, num circles is 10. We're telling Rosemary to draw a circle. Okay, draw a circle of radius 40, and then telling that turtle to move left, and that's going to change every time. Well, not every time. Actually, 360 divided by number of circles, which in this case is always going to be 10, because that's not going to change. So it's going to move left 36 pixels. We're going to add 1 to the count. It's going to come up here and say, okay, is the count still less than 10? If so, run the loop again. But once we've hit 10, it won't do it anymore. So let's run the program. 1 circle, 2 circle, 3 circle. Look at all those circles. Oh, it stopped. It made a lovely little design here. So it did it 10 times because first X was 0. It did it 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it stopped when X equaled 10. So if you want to count them, there are 10 circles right there. There's 0 circle, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when X equaled 10, it now jumps out of the loop because that was the boundary. All right, so let's make some changes to the code, including the value of num circles, and see what happens. All right, let's do 20 circles. How about that? We're going to change this to 20. We're still going to start at 0, so now it's going to do 20 circles. So it's going to count from 0, and 19 will be the last time through the loop. Run the program. And look, they're closer together now. And we've put 20 circles, and it's, wow, that's even a more wild pattern than the first time. But it moved left 360 divided by 20. So 360 is a full circle, right? So it's moving around 360 degrees, and it's dividing that by the number of circles we're making so that they're all evenly spaced throughout all those 20. How about 30 circles? Oh, my. So you can get here and play with this. And look at that pattern. That is a pretty cool. So you can have a lot of fun with this. You can get in here and play with this and change these numbers and see what it does for you. All right, let's look at slide number 4. Read the code, try to predict the output, run program. Okay, look at the output. Are the results what you expected? While loop, define main, total equals 0. So we're starting our count at 0, and we're going to stop when it hits 20. So it'll go through 20 iterations of it. It'll go through the loop 20 times if we're only adding 1 each time. But are we adding 1 each time? Number equals an integer input. Please enter a number. And it's going to print that number. Total equals total plus number. Oh, so the loop's going to be different every time because depending on what I add, that's how it's going to change the total. And then it's going to print the total of all those numbers added together. So this is kind of cool. Look at this. All right, please enter a number. I'm going to enter the number 5. Oh, I'm supposed to still, it went through the loop again. Enter a number. Why? Because the total is less than 20. Okay, so now I'm going to enter the number 6. Please enter a number 2, 8. Oh, my total was 21. Once the total got to where it was greater than or equal to 20, because it only loops as long as it's less than 20. So 19 would be the highest number it would still loop for. But when it got to 20 or higher, it stopped. And there's the numbers I entered. 5, 6, 2, 8. That'd be good if you're playing blackjack, right? You can keep track of your total. And it'll stop when you hit 20 or 21 because you don't want to hit if you get 20, right? So while the total is less than 20, you keep entering numbers. So it only went to the loop 4 times because after I entered 4 numbers, our total was higher. We could run it again, and if we're entering like 3 and 1 and 2 and 4 and 2 and 1 and 3 and 2 and 1 and 3. Oh, let's see how many times I got through the loop that time. I finally got to a total of 22, which was told that it was big enough to stop my loop. But we went to the loop 1, 2, 3, 4, 5, 6, 7. We went to the loop 10 times because the total was still less than 20. 10 times I went to the loop. So this will change how many times it goes to the loop. And you don't know how many times you're going to go through the loop until you know what numbers you're entering. So that's why this works better as a while loop instead of a for loop. All right. Slide 5. While loop, define main. Let's find the total. So that's going to print that first. And then we set the total equal to 0 and answer equal to yes. And we're going to keep going through this loop. As long as the answer is yes, keep doing this loop. So let's see what the loop consists of. All right, so here's the loop. Number equals, please, it's an input, integer input. Please enter a number. That's an integer input. And then it's going to print whatever number that we type. And we're going to add it to the total and ask, would you like to add another number? Yes or no. And if we hit Y for yes, it'll do the loop again, because as long as the answer is Y, it will keep going through the loop until you don't hit Y. Run the program. Enter a number, 12. Would you like to add a number? Yes, add another number. Enter a number, 99. Would you like to add another number? I'll hit Y for yes. Enter a number, 11. I'll hit N. Oh, now it ended, printed my number, 12, 99, 11, and gave me a total of what those three add up to. Now, here's something interesting, though. Just think about this. Enter a number, 44. If I hit a capital Y, I capitalize that Y, the program ended, because it's only looking for a lowercase y. That's why it's good to put the choice. Put the choice in the input statement so the person knows what to type. They know to either type a small y or a small n. Don't type a capital Y, because that's a different thing. Because if I just type this number, I'm going to hit 25 and I type yes. See, that wasn't my choice. I'm not supposed to type yes. I'm just supposed to type Y or N. But if I type yes, it'll end the loop, because the answer is not Y, it's yes. So that's where a user could mess it up. But that's why you give them the choice right there. If you don't put Y/N, they might type yes, because they don't know for sure what you want. So you've got to put the choices in the input statement if you're using a loop, so that they know what exactly to type. Would you like to add another number? Y/N. Let them know. Okay. Let's look at slide 6. Oh, import turtle again. Define main. Trixie, moving at speed 10. Setting the answer to Y. And as long as the answer is Y, here's our loop. And this is a pretty big loop. It's going to be all that's indented. So this is the entire loop right here. Let's see what it does. Number of circles. Integer input. How many circles should be drawn? Integer input. What is the diameter of the circles that are going to be drawn? What color is the turtle? Trixie.color. So we're setting the color by just letting them type a color in when we run the program. That's cool. X equals 0. As long as X is smaller than whatever the user said, because we asked the user how many circles you want, then it will keep going through this loop and drawing circles. Trixie.circle diameter, which that is also entered by the user. And then left 360 divided by the number of circles that the person asked for. Add 1 to our loop. Go through the loop again. Then would you like to draw another? Yes or no? All right, so let's run this. Looks pretty cool. How many circles we drawn? I'm going to say 15. And what is the diameter for the circles? I'm going to say 33. And what color is the turtle? Red. All right, so I drew 15 red circles with a diameter of 33. Would I like to draw another? You're right. Yes, I would. So now it's going to go through the loop again. How many circles should we draw? I'm going to say draw 6. And let's make them 25. And what color? Blue. So I put 6 blue circles inside the red circles. I draw another? Yes, let's do another one. Let's do 55 circles this time and make them a diameter of 48. And let's make them green. Oh, man. I guess I should have moved Trixie a little faster than 10 because that's going to take a while to draw 55 circles. Those green circles are getting drawn on top of the red ones. Probably should have done the green one first, so the other ones will be on top. It's drawing 55 circles on top of the red and blue. Oh, and it don't want to draw another in. And look, 55 is a weird number. It didn't complete the circle because when you divide 360 by 55, it does not divide evenly. So it didn't end up a nice even circle. But this was a loop inside of a loop. See, we had this loop going the whole time. As long as the answer is yes, repeat everything in here. But inside that while loop was another while loop that drew the number of circles. While X is less than however many circles the person entered, we're going to run this loop. So it runs this loop, gets down here, it runs this loop over and over. When it X's that, it's still inside this loop, and it'll run this loop again. So a loop inside of a loop, it'll keep drawing circles until the person says something besides Y, actually. But until they say no, don't draw anymore. All right, here's our last slide. Import turtle, define main. Joe is our turtle. He's going to go to speed of 10. He's going to use the turtle shape. So he's going to show his body when he draws this stuff. And your options are you could be a turtle, an arrow, a circle, a square, a triangle, or just the classic shape that you see all the time. Pick your pen up, move over to position 030. While answer equals Y, and as long as the answer stays Y, we're going to be size 1, so small size. Input, please enter a color, so that's set in Joe's color. Please enter a shape, so we can decide what shape he is. For I in range 15. So this is a for loop. So this is going to run 15 times, right? 0 to 14. And Joe is going to stamp whatever shape we put. And then the size is going to grow every time. And he's going to move forward that size and then turn 30. Turn left 30 degrees. And do you want to continue? Well, let's try this out. This looks interesting. Enter a color. Red. Enter a shape. Let's keep the turtle shape. I want to see this. Oh, there he is. His turtle is getting a little bigger each time, and he keeps going around this circle. Okay. Continue. Yes. Enter color. Blue. Let's make an arrow this time. Oh, see, that's an arrow. So you can play with that and see what all shapes there could be. Let's see classic. Oh, I typed that in the wrong place. It's going to give me an error. Oh, it went black when I did classic. It's similar to the arrow, but it's got the little indentation in the back of it. It's just like a little old-fashioned cursor. But this is a for loop inside of a while loop. We have this while loop, and as long as the answer was still Y or yes, it'll keep doing this. Now, notice there's no line because at the very beginning we told him, pick your pen up. Don't use your pen. Keep your pen up. Just stamp your shape. We just stamped the turtle shape or whatever shape we wanted to use at the time and kept going until it 15 stamps. Because this is a for loop. We know exactly how many times it's going to make it. It's going to do exactly 15 every time because this is a set range. It's not a while loop where as long as something is true, we'll keep doing it. But however many of these things we do is based on the while loop. As long as we keep typing Y every time this box pops up, we'll keep doing it. All right, so that's a little comparison of for loops and while loops. Something a little different to play with. We'll have a program we write on that next week. So let's look at our assignment. When should a while loop be used? What's the proper syntax? Which means exactly how do you write it. Read this code. There's an error in the while loop. What should be fixed? That's a little tricky. You got to pay attention to the syntax. As soon as the while loop condition becomes blank, the loop will blank. Read this code. What output would you expect it to give? when it prints in, which one of these will it print? That's a good question too. All right. There you go. You have your assignment. Just 5 questions this week. We have this week and this next week, and then the final exam. So if you need help writing any programs, if you're having problems with that, A-Day Friday. So I'll be here Wednesday and Friday. Come in and get help. Don't just take zeros because they're 100 points. These assignments are only like 25. So you want to get all your programs turned in. Even if you only get 70 or 80 points, that's better than 0 points. So let's get the programs turned in. There's a template for every one of them in Google Classroom that lists exactly how you have to do things. You have to write it in Python idle. If you write it in some other Python, it's not going to work. If you try to get AI to write it, it's not going to write it in Python idle. It doesn't know what Python idle is. It's not going to work. So make sure you're going through and looking at the sample programs each time. Like this week, I'd go in this and play with that sample program, play with the while loops. Make sure you understand 100% how a while loop works by playing with their sample programs. And their sample programs for all the stuff we've done, all the programs we've had to write. So, all right, guys, even though we got a late start, we still got done on time. So good job with that. Hope you had a fabulous Thanksgiving, rested up, ready for that final push till we get the big break at Christmas, because that's going to be here before we realize it. So, all right, guys, have a great week. Maybe I'll see you Wednesday or Friday. If not, I'll see you next week. So, tackle your week.